This week at NASA. This week, the Kepler science team announced the spacecraft was in a thruster-controlled safe mode. The root cause was undetermined, but the proximate cause appears to be an attitude error caused by a malfunction in Kepler's reaction wheel 4, one of the telescope's pointing mechanisms.
Unfortunately, Kepler's not in a place where I can go up and rescue it or any other astronauts. We're going to look at this data very carefully to see if it's possible to return to a science mode, if we can get a wheel restarted. We do need 3 reaction wheels, we believe, to do the exoplanet science.
The team has since put the telescope in what's known as a point rest state to minimize fuel usage while the investigation continues. Though no decisions have been made about the fate of the mission, the team notes that even if data collection were to end, Kepler has collected substantial quantities of data that should yield a string of scientific discoveries for years to come. Living off Earth, a special presentation at NASA headquarters commemorated the 40th anniversary of Skylab, America's first space station. Panelists included 2 Skylab astronauts and Expedition 34 Commander Kevin Ford. Discussions centered around the contribution of Skylab to long-duration spaceflight missions like those conducted aboard the International Space Station.
The space station was built around what we learned from the Skylab, what they put up there for us, the way the modules were sized and the way they were constructed in space and all that kind of stuff came out of what we learned from Skylab.
And the lessons learned from Skylab will also help us venture farther into space on future missions of exploration, such as the recently announced initiative to send humans to study an asteroid by 2025.
If NASA is allowed to continue and persist in this direction, and with the proper funding to do it, then NASA will continue to be as successful as they have been all the way from Skylab shuttle and space station as well.
During a media briefing at Johnson Space Center, NASA Administrator Charlie Bolden and Center Director Ellen Ochoa discussed the future of human space exploration and the critical role performed by the International Space Station in support of those efforts.
Without station, we cannot develop the technologies and gain the knowledge of the human system that we need to be able to send people to Mars, onto an asteroid, and do the other kinds of things we need.
JSC is home to the International Space Station and Orion program offices and is the primary training facility for NASA's astronaut corps. NASA Deputy Administrator Lori Garver, along with Associate Administrator for Space Technology Mike Gazarek, toured several facilities at Glenn Research Center's Lewis Field in Cleveland, where they were briefed on work being done in advanced manufacturing and cryogenic propellant systems for future extended missions in space, and to advance solar electric propulsion technologies for asteroid exploration.
To have the revitalization of manufacturing be driven by projects such as this that we're seeing at Glenn within NASA research is something we're really, really proud of.
The pair also toured facilities at Glenn's Plumbrook Station in Sandusky, Ohio. The J2X engine being installed in the A1 test stand at Stennis Space Center is the first full engine installed in the A1 in almost a decade. The next generation engine is being installed to prepare it for a new series of tests during which it will be gimbaled or pivoted during test firings. Gimbal tests are an important part of the J2X design process because in space, the engine must move freely to steer the upper stage of the Evolved Space Launch System, NASA's new heavy-lift launch vehicle. This is the first round of engine gimbal testing to be performed since testing of the Space Shuttle main engines.
For Langley Research Center.
NASA Aeronautics Research took center stage when Administrator Charlie Bolden visited the Langley Research Center in Hampton, Virginia. Bolden and local media checked out a lab that tests cockpit technologies that help transform the National Air Transportation System.
It depends on the aircraft, but we are now at a constrained waypoint that has 280.
They also got a look at a NASA Langley simulator researchers use to develop systems that make airplanes safer. Former naval aviator Bolden got the chance to land the virtual plane in near zero visibility with the help of new cockpit displays.
It gives you all the right directions, you just got to be able to follow them. But it's good, I was impressed.
Following a 5-state journey that began in Colorado, Sierra Nevada Corporation's Dream Chaser engineering test article made its arrival at Dryden Flight Research Center in Edwards, California, where it will begin a flight test program in collaboration with NASA's Commercial Crew Program. Dream Chaser will undergo tow testing to validate performance of its nose strut, brakes, and tires, captive carry flight testing to examine the loads it will encounter during flight, and pre-flight tests to validate aerodynamics. The flight tests will draw upon the experience of NASA Dryden in conducting various approach and landing flight tests, including testing the Space Shuttle prototype Enterprise in 1977. A NASA Google Plus Hangout carried live on NASA television connected NASA astronauts with cast members of the new film Star Trek Into Darkness to discuss how work aboard the International Space Station is turning science fiction into reality.
There's commercial companies coming online. Would you ever, if money was not an object, would you ever buy a ticket and come up and visit?
Yes, 100%.
Done. I'm in. We'll see you on Friday.
I would love to go.
Flight engineer Chris Cassidy from on board the station and other astronauts from Johnson Space Center discussed life in space with movie director J.J. Abrams and actors from the film, and took questions from followers of the Hangout from the Intrepid Museum in New York City and the Smithsonian National Air and Space Museum in Washington. Details about upcoming NASA Google Plus Hangouts can be found at www.google.com/plusnasa. On May 20th, 1978, the Pioneer Venus orbiter was launched and reached Venus on December 4th that same year. The Pioneer Venus project consisted of two spacecraft, the orbiter Pioneer Venus 1 and the multiprobe, or Pioneer Venus 2, which was launched separately on August 8, 1978. The main objective of the program was to investigate the solar wind in the Venusian environment, map the planet's surface through radar imaging, and study the characteristics of the upper atmosphere and ionosphere. The first global topographic map of Venus was constructed from data collected by Pioneer Venus 1. And that's This Week at NASA. For more on these and other stories, or to follow us on Ustream, Flickr, and other social media, log on to www.nasa.gov.